So you can change the page.
Yeah, what?
I say you can either change the new page or we carry on from where we are.
Yeah, we will just carry on from this point.
Okay.
Yeah. So this is the homogeneous case, right? What will be the characteristic polynomial?
Is 4, let's say lambda square. Plus
Lambda
minus
squared?
4 lambda plus 1 equals 0.
It's going to be 4 lambda squared, right?
Yeah.
Minus 4
Minus
lambda.
4. Yes.
Plus
1 equals 0.
1 equals 0. And then we can solve it, right?
Yeah.
I think this is going to be 2 lambda. 2 lambda minus 1 equals to 0, but let's see. So this is 4 lambda squared. We can split the minus 4 into, so we are looking for 2 numbers. Their sum should be minus 4 and their product should be 4. So which 2 numbers would work for this case? Is it possible to factorize this?
We can look for the discriminant and work the way.
Okay, so let's use the quadratic formula. So lambda is going to be equal to 4 plus or minus the square root of negative 4 squared is 16, right? And then 16 minus 4.
4 AC.
16 minus 16 divided by 2 times 4, 16. So the discriminant is 0. So
no, 2 times 4 is 8. 2 times 4 is 8.
Okay, 2 times 4 is 8. Yeah. So in this case, we are going to have a solution. So this is a case where lambda 1 is going to equal lambda 2, and it's going to be a half, right?
Yes.
So what is the solution? So the homogeneous solution is going to equal, we can go up to the table up there.
Yeah, I got it here.
So this is case 2.
Yeah.
It's going to be A plus BX powered by a half
exponential. Yeah. Is it not exponential?
Let's check again. Exponential a half x.
Yeah. E.
There you go. And that's going to be the solution that we were looking for, right?
Yeah. That in this case, we need to look for A and B as well.
We don't have the particular, we don't have the initial conditions.
Okay. Can we make up one?
Yes. Let us look for another example. Maybe we can go for the non-homogeneous case, right?
Okay.
Let's go for the non-homogeneous case. So, yeah, okay. We have this one.
Okay.
I'll call it example 2. So we want to solve this second order differential equation. It's d the second derivative minus 5 multiplied by the first derivative plus 6y. And this is the non-homogeneous case.
Yes.
20e to the power of negative 3x.
Good.
So what do we expect? We expect our solution to be y equals, so this is what we expect. We expect to get the homogeneous solution, YH, plus the particular solution, right?
Yes.
YP. And we want this, a combination of these two is going to become our solution to this ODE, okay?
Yeah.
So what is
And
the
you said there were going to be some initial conditions.
Yes.
Have you got any?
So the initial condition that we have here, we have y of 0 is 5. And then we also have y prime of 0 is 3.
Okay.
Those are the initial conditions. So we can start off by looking for the homogeneous solution, YH.
Yes.
So the associated polynomial.
Lambda square minus 5 plus 6.
Lambda squared minus 5 lambda.
Yeah, lambda, sorry. Yeah, plus 6 equals 0.
Equals 0. What will be the solution? I believe this can be factored into lambda minus 2 multiplied by lambda minus 3, right?
Yes.
Meaning
equals
that,
0.
yeah, meaning that lambda 1 is
Equals
2.
2. Yeah.
And lambda 2 is 3.
Yeah.
I believe this is our first case. This is going to be the first case for homogeneous solutions. And so YH is going to equal
YC. Oh, yeah.
Okay,
Equals
I am using
A.
H for homogeneous because I'm used to H, but it's YC in your notes, right?
Yeah, it's okay. Let's carry on with yours.
Yeah.
This is A, lambda 1, 2x.
It's going to be
plus
AE
B,
powered by 2x.
Yes.
Plus B
BE
powered by
3x.
Powered by 3x. Okay. Now, as for the particular solution, we are usually guided by this. You see this, the f of x?
Yeah.
It's going to tell us how the particular solution is going to shape up, okay? So we expect our particular solution to take the shape of fx, okay? So we expect some constant c e powered by negative 3x. So that's what we expect for the particular solution. Are we together up to that point?
Yes.
Okay. And this particular solution, it should be a solution to the ODE, right?
Yeah.
Meaning that if we were to do a first derivative on it, dyp dx, what do we have? It's going to be
dyp
dx. It's going to be, we are differentiating the yp equals c negative, the power of negative 3x.
Minus 3. Okay, I'm waiting for you.
Oh, all right. So it's going to be minus 3.
Minus 3c exponential minus 3x.
Very good. How about the second derivative? dyp dx2. Second derivative, it's going to be
9c
9c
exponential minus 3x.
exponential minus 3x, right? So we believe that this is a solution to the differential equation, right? So if we go back to this differential equation, and then we replace the second derivative with the 9c exponential negative 3x, and then we do the same with the dy dx, right?
Yeah.
So this is going to be 9c exponential negative 3x, and then minus 5 dy dx. dy dx is minus 3c exponential negative 3x.
Minus 3x.
And then we got 6y. So this is going to be plus 6 c exponential negative 3x. And this equals 20 exponential negative 3x, right?
Yeah.
So this only means that 9c plus 15c plus 6c
equals 20.
equals 20, right?
9c
plus 6c is 15c plus 15c again we have, that is
30.
c equals 20, and this only means that c equals 2/3.
2/3. Yeah.
And so the particular solution that we were looking for, yp is going to be 2/3 e to the power of negative 3x. And so the solution to this non-homogeneous ODE is going to be the homogeneous solution A e to the power of 2x,
yeah,
plus
b exponential 3x
plus 2/3 exponential negative
minus
3x. Okay. So I think for us to solve the C, the B, and everything, we need the initial conditions.
Yeah.
Yeah. So we know that y of 0, the initial condition told us that y of 0 was 3, right? No, y of 0 was 5.
5.
So this only means that a e to the power of 0 is 1. So a plus b plus 2/3 is equal to 5, right?
Yep.
And so this is going to mean that a plus b is equal to 5 minus 2/3. It's going to be 4 1/3. Right?
Yeah. I don't understand that notation.
Which one?
5, 4 1/3.
Oh, what do you understand? Like 5. I subtracted 2/3 from 5.
Yeah, which is 15.
And then I got 4 1/3.
Yeah, 13/3.
Yeah. which is the same as 13 thirds, right?
Yeah.
Next, we have y prime. First of all, what is y prime of x? Let us differentiate this. Is it going to be 2a e to the power of 2x plus 2b e to the power of 2x plus
no, minus 2.
Yeah, it's going to be minus 2 e to the power of negative 3x, right?
Yeah.
And then we have y prime of 0 is 3.
Yeah.
So y prime of 0, it's equal to 2. It's going to be 2a plus 2b minus 2 equals 3, right?
Yeah.
And this would only mean that 2a plus 2b equals, no, this is, wait, there is a problem.
Hmm? Yeah.
There is a problem somewhere.
Why?
Let's see.
Why
Yeah, I see the problem. YH was AE2X, BE3X, right?
Why
So
are
this
we?
is a 3.
Why?
Here. You should make sure you have a 3. BE to the power of 3x.
Yeah. Yeah.
And this would also be a 3. As well as this one. Yeah, I realized there was a problem because I saw we were coming up with 2 linear equations that were dependent. That's why. This is also a 3. So 2a plus 3b equals 3. And now this makes sense, right?
Okay.
So to solve a and b, we need to get this equation. And we also need to get this other equation. So the a plus b equals 13 thirds, right? A plus b equals 13 thirds.
Yeah.
And here we have 2 thirds a plus b equals 1. I divided the second equation by 3. I got 2 thirds a plus b equals 1.
Is it that way?
Yeah.
We could have left it equals 3 and multiply the top one, is it?
Oh yeah, that's another way of doing it. I could have left it to be like that, and then I multiply the top equation by 3. Yeah.
Okay.
So you could talk of 3a plus 3b equals 13.
Yeah.
And then 2a plus 3b equals 3.
Yeah.
3a minus 2a is 8. 13 minus 3 is 10, right?
Yeah. Yeah.
And then 3, so 3b is going to be 3 minus 20. 3 minus 20 is negative 17. B is going to be negative 17 over 20.
Hold on. Over 3.
Negative 17 over 3.
Yeah.
Yeah. And that should make sense, right? Yeah. So let me see.
You mean for the value of A and B?
Yeah, A is 10 and B is negative 17 thirds.
Okay.
Yeah. Let me check what they have. Oh, 1 second. Look, I'm so sorry about this. We are making mistakes. There was a -2 here, right?
Yeah, coming from up there.
Yeah, there was a -2, meaning that if we added it to the 3, this should have been a 5.
Yeah.
And then
the 2B.
this should have been a 5, right?
Yeah. And the 3B should be 2B.
Which one? No, I think it's okay.
No, how do we get the 3B then?
Which 3B? Which one?
The one we just changed the 5. And 2A plus 3B.
No. This should be a 2B. It should be a 3B. It should be a 3B. Yeah.
Okay.
Look, it should be a 3B.
No, it's fine.
Because
it's fine.
this is a 3B, yeah.
Yeah. Okay. So now we can have this off and try to resolve that equation again.
Yeah. So if we try to solve it, if you do 3A minus 2A, you get A. 13 minus 5 is 8. Right? And so A is 8. Everything is okay now. So far, so good. Yeah. And then if A is 8, then 2 times 8 is 16. 5 minus 16 is going to be?
11.
Negative 11. Divided by 3. Yeah, those are the correct values. And so the final answer, final solution should be y equals A, which is 8, e to the power of 2x plus b to the power of 3x. So 8e to the power of 2x minus 11 thirds e to the power of 3x plus 2 thirds e to the power of negative 3x. That should be the final solution.
Okay.
Yeah. And it makes a lot of sense. Yeah. I don't know. Did you get the hang of it? Did you get the flow?
Yes.
Yeah. So the particular solution will always take the shape of the function of x.
Yeah.
Yeah, always. Let me look for an exercise now.
Yeah.
Okay.
Check again. There's light on the corridor. Are you not having your dinner? There's light
Yeah,
on the
this one is
corridor.
interesting. So the next one we got second derivative plus the first derivative plus y equals 2ex plus 3x plus 4.
Okay. Interesting.
Yeah. So our solution is going to be, of course, y equals the homogeneous solution plus the particular solution, right?
It will depend of the auxiliary solution, isn't it?
Yeah. The
Then,
homogeneous solution will depend on the characteristic polynomial.
okay. Yeah. Yes.
So our polynomial, the associated polynomial is going to be lambda squared plus lambda
plus 1
plus 1 equals 0. And using the quadratic formula, this is going to be -1 plus or minus the square root of 1 minus 4
minus
divided
4.
by 2. Right?
Yeah.
So here we are talking about -1 plus or minus the square root of -3. This is going to be 3, the square root of 3, I, right?
Yeah.
Divided by 2.
Wow.
So
Can you check that? Can you check that we took the correct one?
which one?
The equation from the OED up there, is
The
it?
ODE?
Yes.
You are doubting it?
Yeah, this, for an example, is a bit complicated.
Yeah, that's the ODE is the correct one, and we got complex
read it,
solutions.
please.
Yeah.
Read it, please.
What?
Is it the? Read the OED, please, as it is on the paper.
Okay. So it's the second derivative plus the first derivative plus y equals 2 exponential x plus 3x plus 4.
Okay. Wow.
Yeah. It looks like that. Okay. And this is the solution. You can see I used the quadratic formula properly. Our b is, our negative b is -1 plus or minus square root. 1 squared is 1 minus 4 divided by 2, and this is going to be the solution. Can we write it like -1/2 plus square root 3 over 2 plus or minus square root 3 over 2 I, right?
Yeah.
So the solution is complex, so we have to go up and look at the cases. And I believe this is going to be case number 3.
Yeah.
And according to case number 3, our lambda is -1/2, and our alpha is -1/2, and our lambda is √3/2, right?
Yeah.
And so we are going to have E negative lambda x multiplied by A cos lambda is going to be √3/2 x plus B sine √3/2x. Oh, another small mistake. This shouldn't be B in the cases. It should be lambda.
Yeah.
Yeah. So we go down with our homogeneous solution to this problem. It's going to be YH. So the homogeneous solution YH or YC is E -1/2 x multiplied by A, the cosine of √3/2x plus B multiplied by the sine of √3/2x.
Yeah.
There you go. Yeah, if the homogeneous solution was not complicated, I'm already afraid when it comes to the particular solution. So YP, we expect YP to take the shape of fx, right?
Yeah.
So it should be CEX plus DX plus E. You realize I just went up to this ODE and then I picked the fx, this function, and then I just replaced the coefficients, the constant coefficients 2, 3, and 4. I replaced them with C, D, and E, right? Yeah. So what is going to be the first derivative of this thing?
No, Steve, please go. I'm not getting. Yeah, this is the example. The
Yeah.
particular solution will take the shape on.
Yeah.
2.
It will take this shape.
Yeah.
So it's going to have some coefficient. The coefficients need not be the same. So it's going to have some coefficient, maybe C, and then EX, some other coefficient instead of 3, D, X, and then some other coefficient to replace 4, E.
Okay. Yeah.
Yeah. And if we get its first derivative, this is going to be CX. No, this is going to be CEX, right?
Yeah.
Plus D. Then the second derivative
is CEX.
CEX. And because we believe it's a solution to the ODE, we can go back up and make our substitutions. So instead of the second derivative, we can have CEX. That takes the place of the first derivative. No, the second derivative. And then we move on to the first derivative, which is CEX plus D. And then the last CEX plus D. And then the last guy It's just, what was it? It was y, right?
Yeah.
So it's going to be
CEX plus DX plus E.
plus dx plus e. And this is equal to 2EX plus 3X plus 4, right?
Yeah. Can we confirm that 2EX plus 3EX, 2EX plus 2 plus, yes.
Plus 3X plus 4.
Mm-hmm.
So we simplify our left side. This is going to be 1, 2, 3. It's going to be 3CEX plus DX plus D plus E, right?
Okay.
Because
2EX
plus 3
plus 3 plus 4.
plus 4. So what does this mean?
It means that 3C equals 2.
This only means that 3C is 2.
Mm-hmm.
And so C is 2 dots.
Yeah. And D is 2. D is 3.
D is 3. And E is 1. Right?
And E is 1.
Yeah.
Yeah, we got D plus E equals 4.
D is 3.
Okay. Yeah, that's fine.
So the particular solution, YP, is going to be C is 2 dots. So 2 dots EX. 2 dots EX plus 3X plus 3X plus 1. And so the overall solution, it's going to be a combination of the homogeneous solution, which was this big guy, e to the power of negative a half x multiplied by a cos, multiplied by a cosine square root of 3 over 2x plus b sine square root 3 over 2x plus b sine square root of 3 over 2x plus 2 thirds EX plus 3x plus 1.
Yeah. Did we have any initial condition?
I don't think we did.
Okay.
I don't think. Because if we had initial conditions, you can imagine how tough it could have been, because you would need the first derivative of this general solution, the second derivative,
Wow.
and then use those derivatives to get the coefficients A, B. And I guess that is something you wouldn't want to do. Maybe the question knew that we don't want to do that. Yeah. Yeah, I think we've done something today. Where was your problem in particular?
It was just to practice like that.
Okay.
And get it stick in my mind.
Oh.
Even, yeah.
Yeah, I'm asking because I didn't see you struggle.
Mm.
Yeah.